Welcome to Logarithmic Functions. Today's objective is to write equivalent forms for exponential and logarithmic functions, and also to write, evaluate, and graph logarithmic functions. So we want to figure out what exactly logarithmic equations are. Now, it's really helpful to think about them as another way to write an exponential equation. So, for example, if we had an exponential equation of base b raised to the x equals a, the way to write this in logarithmic form is to write it as log base b of a equals x. So we want to get in the habit of recognizing that the base of the exponent will be the base of our log. The answer, which is on the right side here, will be this term here, and the variable, or whatever b is raised to, that's going to be our answer. Okay, so let's look at some examples of writing exponential equations as logarithmic equations. So I'll just write a line here, separate it. So for example, if we had 2 raised to the 6 equals 64, the way to write that in logarithmic equation is to figure out, well, the base is 2, so I know I'm going to be writing log base 2 of 64 equals 6. Now if I had 4 raised to the 1 equals 4, the way I'd write that, my base is 4, so I do log base 4 of 4 equals 1. If I had 5 raised to 0 equals 1, I write log, my base here is 5, of 1 equals 0. So here are 3 examples, but none of these have variables, so let's look at what one of these would look like with variables. So if I had the equation 3 raised to the x equals 81, here I'd be solving for x. So this is where it's helpful to learn about logs. So our logarithmic equation would be log base 3 of 81 equals x. So this is a way we can solve for x, and we'll get into more how to write these logs in terms of something we can calculate, but for now we want to get the annotation down. So let's do a few more examples of taking exponential equations, which are these right here, and writing them in logarithmic form. So I'll just write log form right here. So here we have 9 squared equals 81. Now to write that in log form, we write log, our base is 9, so 9 goes down here. Our answer is 81, so we're taking the log base 9 of 81, and that's going to equal 2. So the answers here are just whatever these exponents are. Okay. Next one, we have 3 raised to 3 equals 27. So we're going to have log base 3 of 27 equals 3. And let's do this last one. Here we have x raised to 0 equals 1. We know anything raised to the 0 equals 1, but we're specified here saying that x cannot equal 0. So we have log base x of 1 equals 0. We've studied how to go from exponential form to logarithmic form. Now let's study how to go from logarithmic to exponential. So in this first example we have log base 10 of 100 equals 2. Well, we know that this number here, 10, that's going to be the base of our exponential form equation. The right side here is our exponent value, which is 2. And we know 10 squared equals 100. For the next one, we have log base 7 of 49 equals 2. So our base here is 7. We're raising 7 to 2. And 7 squared equals 49. So for the next one, we have log base 8 of 0.125. Now, this here is supposed to equal negative 1. So we have our base of 8 raised to negative 1 equals 0.125. For our next one, we have log base 5 of 5 equals 1. So we have a base of 5 being raised to 1, and that's just 5. And for our last one, we have log base 12 of 1 equals 0. So our base of 12 is being raised to 0, and we know anything raised to 0 is just 1. Let's try a few practice ones to make sure we understand what we're doing. So now we're going from log form to exponential form. So for our first example, log base 10 of 10 equals 1. We know our base is 10, being raised to 1, that's just 10. For our next one, log base 12 of 144 equals 2. Our base is 12, being raised to 2, and that's just 144. And for our very last one, here we have a base of 1/2 being raised to the right hand side, which is negative 3. Now, without looking at 8, let's see if we can figure this one out algebraically. Well, we know anytime we have something raised to a negative exponent, we flip it. So what it really is 2 raised to 3, and we know that equals 8. There may be a few special properties of logarithms you might have noticed already, but let's give some names to them so when we're talking about them we know that we're all on the same page. So let's look at an example of a certain exponential form property. So if I have any base raised to the number 1, that's just going to equal b. So for example, let's say we had 10 raised to the 1. We know it's just going to equal 10. And the logarithmic form to write this, we know that the log base 10 of 10 equals 1. So basically, anytime you have a base raised to that same number, the answer is just going to be 1. Now, let's say we had a base raised to 0. Well, we know anything raised to 0 is just 1. So, for example, let's say I had 10 raised to 0. We know it's just going to be 1. Now, in logarithmic form, if we have log base 10 raised to 1, we know that's just going to be 0. So the two properties that we've learned is anytime you have a number raised to that same number, right here in logarithmic form, the answer is just going to be 1. And anytime you have a base raised to the number 1, the answer is just going to be 0. In this first example right here, we used a log with a base of 10. Now this right here is called the common log. Now the way you're going to see this written in your books is, for example, you'll see the word log and then a number 4 or 3 or anything after that. If there's no base down here, it's just a common log. So if there's no base, that's the common log. So if there's no base written, that's the common log, which is a base of 10. So it's just kind of implied. If there's no number here, no, that basically there is a number there, but it's just 10. Now further on in this chapter we're going to do some logarithms with calculators, but with using the information that we know now, we can do some logs with mental math. So let's look at this first example. The log of 1,000. So the first thing that we know is that since there's no base written here, we know it's technically a base of 10. So we can rewrite it that way for now. So we can think of it as log base 10 of 1,000. Now, if we're going to rewrite this in exponential form, and I recommend doing this sometimes at the beginning to get you used to it, what this technically would say is we're trying to figure out what to raise this to get 1,000. So, what do we raise 10 by to get 1,000? So I can write that in an algebraic equation. So I have the number 10. I don't know what I'm raising it to, so I can say that's x, and I have to equal 1,000. Once again, exponential form, logarithmic form. Now here we have, this is something we can do in mental math. Basically we're thinking, what number do they multiply, how many times do they multiply 10 by itself to get 1,000? So we know that 10 times 10 times 10 equals 1,000. So our answer here is 3. So the answer to this log of 1,000 equation is just 3. Okay, let's try the next one. So the next one we have log base 4 of 1/4. So the question is, what do we raise 4 by to get 1/4? So if you kind of just look at these two numbers here, you see the only difference is that this is 4 over 1, this is 1 over 4. So we have to raise 4 by something that's going to make it flip. Now we've studied exponents and the rules of exponents, and we know that if we raise anything to the -1, it will flip. So here we know x has to equal -1, because 4 raised to the -1 equals 1/4. So your answer here is -1. So on a quiz or a test or on a homework, if you were writing this as log base 4 of 1/4, the answer would be -1. Let's try two more practice ones of this mental math technique. So first problem I'm going to do is the log of 1,000. Now let me just rewrite this, because if I write it in fraction form it might be simpler to see. It's the log of 1,000. It's 10th place, 100th place, 1,000th place. So it's 1 over 1,000. So there's no log, there's no base to this log here. So I have to remember that that means this really is written as log base 10 of 1 divided by 1,000. So my question is, what do I have to raise 10 to get 1,000? Well, I know that I have to flip this, so my x value has to be some negative, but then how do I get 10 to equal 1,000 using exponents? Well, I know that 10 times 10 is 100, and 10 times 10 times 10 is 1,000. So if I raised 10 to the -3, I'd get 1 over 1,000. So the answer to this one is -3. Okay, let's try this next one. We have log base 25 equals 0.04. My recommendation would be to rewrite these as fractions, because it's easier to see what's going on. So this is 4/100ths, or 1 over 25. So the question is, what do I have to raise 25 to get 1 over 25? And we very easily see that all we have to do is flip it, so we raise it to a -1. So the answer for this one is -1. So because logarithms are the inverses of exponents, we can see that in their graph, they're basically being reflected by that same y equals x line. Now, one thing you'll notice is that if you examine the domain and ranges, they basically flip, which makes sense, because they're inverses of each other. So let's look at the domain and ranges of these equations and see if we notice any differences or similarities. So I'll use blue for this one. So the domain for y equals 2 raised to the x is all the possible x values. Now there really is no limit here, so we'll say all real numbers. Now the range, well, there is a limit to the y values. We see they kind of start to bottom out and they don't go past that y equals 0 line. So the range is all values of y that are greater than 0. So now let's look at the domain and range for our log equation. Well, just by looking at it, we can see that there is going to be some type of limit to the domain. They said they don't go past this value here of x. There are no values of x down this way for this log equation. So we'll say the domain here has to be all values of x that are greater than 0. Now for the range, there'll be no limit. The y will continue further down here, all the way down, and the y will keep going up and up and up and up. So the range is all real numbers. So we can see how the domain and range is basically flipped. So if you knew the domain and range of the exponent equation, you'd know the domain and range of the log equation. So that's it for today for exponents and logs. I hope this was helpful. Thank you. Take care.